what is important at this stage is to exactly understand what we mean by this Internet of Things. What is the definition of IoT? By far the best definition I could ever look up and understand is from the ITU. Okay. What that definition actually says is that it is a global infrastructure for the information society. Okay. So, when you say we live in this information society, right, when you say information society, it is all about creation of information, manipulation of information, access to that such information, right. So, it says global infrastructure for the information society enabling advanced services by interconnecting physical and virtual things based on existing and evolving interoperable information and communication technologies. Amazing definition, perhaps well done and quite concisely put. Look at what all it says. It says physical objects and virtual objects. What do we mean by virtual? Virtual are those objects which are intangible, you do not see them, right. For example, you can talk about a paper which is something physical that you see. When you say e-paper or you say e-book, it is virtual, right. So, that is a virtual object. So, it says interconnecting physical and virtual things based on existing and evolving interoperable information, that is already what is there plus what are the new things that we are likely to bring in, technologies which are likely to bring in so that they are evolving and interoperable information and communication technologies. So, that is really the key here. So, now let us, so if that is indeed the definition of what an IoT is, everything around us is a thing, what you see around you are actually things. You can talk about this chair which is a thing, and you can be talking of this computer or a laptop which is another thing, and you want the chair to talk to this computer. How do you enable that? Look at what is funny about the look at what I have exactly what actually I have said. I said a chair and a laptop, these are two heterogeneous objects, and you can just look at how these two heterogeneous objects actually work or how actually you can enable. One simple idea you can say is, if a person sits on this chair, the laptop switches on, right. So, that is something that one thing can inform the other thing that it has to switch on. A very simple IoT system, two physical objects talking to each other with no human intervention for the betterment of many things, like what? It could mean savings in power. For instance, the laptop switches on only when the person sits on this chair, which means there is a sensor connected to this system which senses the presence of a human, and once it senses that, it gives a signal to the laptop and says, okay, now there is a human, why do not you switch on, right. All through the laptop was off, which means you are saving a lot of power, right, you are saving a lot of useful power, and that way you enable two things to talk to each other and exchange useful information for the betterment of mankind, right, in a very large context, for the betterment of the whole system, the whole universe here. So, that is really a very nice definition of what ITU actually put in. You could actually be even trying to connect virtual objects, right. So, it also says virtual objects. For instance, when the person sits on this chair, the laptop switches on and opens the e-book, okay. So, now what is actually happening is the laptop, which is a physical thing, is triggering a virtual book which actually does not exist, right, in terms of a tangible presence. So, now the human is actually accessing a virtual object through the laptop, which is a physical object. So, all of this actually falls into the paradigm of what ITU actually defines for what an IoT definition is all about. So, let us leave it at that stage and not get into hopefully this is a nice way of putting what the definition of an IoT system is, and then let us move on to understand this from a very practical perspective of how you can actually put together a nice IoT system in place which will do all the important which will meet all the important requirements for us. Let me show you this picture. Okay. This picture essentially has IoT devices. You can see there is one device here and you can have n such devices all over, right. And these IoT devices you can see are either battery driven or energy harvested. You could be doing it both ways. All these IoT devices basically are essentially are basically equipped with sensors which sense something from the environments here, right. Some environments here they are all sensing those environments. Basically all these sensing environments are analog by nature, but nowadays you can also be looking at analog information directly sensed data is directly processed and digital information being available, digital data being available directly to these IoT devices. Essentially you could be processing the analog information, analog data into digital data and making it available directly on to these devices. So essentially it is sensing some environment. All of them are pushing data to what is known as this gateway device. Okay. Now what is the difference between this IoT device and this gateway device? Well, you can imagine that a IoT device maybe might not even exceed this size. This is a small PCB which has some circuitry here, has a chip here, has some connectors here and has some sort of a storage here, and typically you can be talking of a size which is maybe something like 2.5 centimeters, no I would say let me put the length in place, about 5 centimeters in length and roughly 2 or 2.5 centimeters in its breadth. Okay. But if you really talk of a so this is I would say the maximum size of what an IoT device can actually look like. But if you look at the gateway device, I think to just maintain proper proportion I will remove this gateway and show this gateway a little bigger. Okay. So now I will say gateway, alright. So this gateway essentially is bigger in size, and if you want to know what is a comparable, what do you mean by bigger in size compared to an IoT device, you must have come across many of these off the shelf boards which are available, this which includes the Raspberry Pi is a very good example of a gateway device, Beagle board is one such example, Odroid is another example, Beagle Bone is another example, Edison from Intel, Edison based board could be another example, Galileo based board from Intel is another example. So you have a bunch of these boards which can, or Arduino based boards for instance, I forgot Arduino, a very important component available, important hardware which is available and very popular in its usage. So Arduino, Mbed for instance which uses ARM Cortex at 100 megahertz processors, this are also called the Mbed boards which are there. It could be Intel Edison board, it could be Intel Galileo board, it could be TI's Beagle board, Beagle Bone, or it could be Raspberry Pi. Any of these devices which look slightly bigger in size can actually form a gateway device. And what should it run? It should run an embedded OS, typically something like open source Ubuntu. Okay, so sorry, this U looks little strange, so let me write it again. This is Ubuntu. Typically it can run an operating system, an embedded operating system like Ubuntu, and it also it's basically a Linux distribution. Ubuntu is basically a Linux distribution, and it runs all the required necessary packages which will allow us to connect out. So what is the paradigm here? The paradigm is IoT devices are continuously sending data to this gateway device, and for what purpose? Well, if you have to really come and look at what purpose is this data getting transferred from IoT devices to gateway, you have to understand that in an IoT system there are some essential blocks, and let me start putting down those important blocks. One of the blocks essentially are, let us begin with what we understand very well, these IoT devices, right. So IoT devices which we know are from 1 to n, and we of course know that there is this gateway, right. So data is actually going in this direction to this gateway, and now we will introduce a new term here, okay. What we will call this gateway could essentially not just look like the size of what we mentioned like TI BeagleBoard, BeagleBone or Raspberry Pi or Intel's Edison, Galileo or any one of them, but actually a little more bigger. It could actually be the size of, let us say, a typical IP router, okay. So such a device actually has a, this kind of device actually has a bigger name in the context of IoT, and such devices, such names are actually called edge devices, okay. It might turn out that gateways can in turn connect to an edge device, which means it has to be bigger than that of a normal gateway. It is bigger than a normal gateway. It has much more. When you say bigger, essentially we mean not just in terms of its physical appearance, but also the fact that it can process a lot more data. It can do lot more interesting smart handling of the explosion of data happening from these IoT devices could actually be handled by this gateway device. It now clearly indicates that you have a choice whether you want to connect this gateway directly out to the internet, or you want to pass the gateway to another edge device which in turn connects to the internet, right. Either this or both, right, which means the internet system itself can have. So let me redraw this and show that this is a possibility to connect, this is a possibility to connect, this is the internet, this is a possibility to connect, or this is another possibility to connect. Very good, and this is essentially what we call the internet, right. So without getting into the detail. Very good. So why should you have an edge device and why should you have a gateway device? We will come to those detailings a bit later, but for the moment just assume that you could either do it directly or through this edge devices. Just to sort of make you think a little bit more why these two options actually exist, let me just give you what is actually happening in today's world, okay. Just look at this picture. You have a huge amount of data which is being generated. Assume that 16 bits of data which is coming from an analog sensor is coming out every second, right, and there are n such devices. So you have n times 16 bits coming out every second, and just imagine the amount of data that you will collect in 1 minute, 1 hour and 1 day, huge amount of data, and all the data will either have to pass through this gateway device or pass through another alternate route. One simple way is you use this gateway purely because of the fact that these IoT devices do not talk the de facto internet protocol, which is essentially TCP IP. They in fact talk something, some protocol, some simple embedded code which essentially can communicate in its minimalistic way to this gateway, and gateway now takes the responsibility of saying, okay, you guys have given me data on a protocol that I understand very well, but if I have to push this data onto the internet, I have to convert this data into the de facto internet protocol standard, which is indeed TCP IP. Therefore, you can see now that IoT devices often, because of their memory constraint or processing constraint or any one of these being constrained devices, are unable to talk standard protocol, which puts the pressure on the gateway to do a simple gateway translation, protocol translation of taking data from these IoT devices and putting them out on a protocol well understood over the internet LAN. Very good. So, this is one very nice function that the gateway can essentially take responsibility of. Now let us assume you want to make the gateway a little more smarter, okay, and you want to tell let us say there is intelligence on the gateway, what kind of data is actually being sensed. It could be, let us say, data coming from the field, essentially from an agricultural field, which could mean temperature, ambient temperature, it could be pressure, it could be soil moisture, right, and it actually knows what is the kind of data that is being sensed, and therefore what it decides is that, okay, now that I know something about the type of data that is being sensed, let me do something more intelligent in terms of performing summary of the data that is being collected, in terms of averaging data, okay, or picking the maximum value or the minimum value, or taking an average and then transmitting that data over this link to the internet. Often you may do even more complicated analytics on the data, you may do a lot of processing on the data, and that is the reason why gateway often may not be a good choice to give data directly to the internet. Instead, you ask the gateway device to collect data, you collect data and give it to the edge device, so that the edge processing can actually help either duplication, removal of duplication of data, or do a lot more complicated processing beyond this, very important, beyond these simple functions, right. So, now you have come to this model, and I have sort of given you a sort of a motivation why sometimes it is useful to pass data directly to the internet, hence why sometimes it is useful to pass through a little more powerful edge device. Okay, so which means our first element of the internet of things, call it the architecture, is finalized. You basically talk about an edge device, alright. What is the second one? The second one is all to do with complicated, let us put down that. First thing is the edge device, right. Once the edge device uploads data, processes the data and reduces the amount of data that is constantly exploding from these devices here, exploding from these devices here. These are the data exploding devices, and somehow does some sort of summarization and uploads the data. Remember, what it means is it has done some very simple things, and sometimes if it is a edge device it has done something more. In any case, further processing of this data is required, which brings us to a very important part of the IoT architecture, storage of the data either locally or on the cloud. Okay. It could be either local storage or it could be cloud storage. So, this is the second element you can say which is part of the architecture. The third one, perhaps once you have rested the data, pushed the data, stored the data, the data is in a resting condition, you want to act on the data and perform another important block called the data analytics. So, you run analytics on the data. What use is this analytics on the data if you are not able to use it, if you are not able to visualize it? So, this is the third block, this is the fourth block of our architecture, which clearly indicates that when you talk of an IoT system, you talk of 1, 2, 3 and 4 all the time. Many variations exist, many ways of looking at this whole system can be there. Storage, you need not necessarily be talking of just cloud storage, you could be talking of local storage within the LAN, within the system, within the environment. In any case, there will have to be analytics so that the data that is stored is made useful. You make sense out of the data by running it through analytics engines, essentially, which will allow you to process the data, and of course everything has to be very useful for us to visualize this data. So, keep this in mind that you have 1, 2, 3 and these 4 devices, 4 different blocks which form the architecture of this of an IoT system, which means now we have to get into details of each one of these blocks. Of course, our discussion will by and large be around creation, design of these IoT devices, how is data transferred to this gateway device, and how do you ensure that data from these sensors are gathered reliably, gathered and processed reliably and transferred to these gateway devices. Let us now see what an IoT device actually contains. Thank you very much.